Yeah, dear guests, ladies and gentlemen, dear colleagues, welcome to the session 13. The title of the session is Implementing Blue-Green Infrastructures, Challenges and Opportunities. My name is Roland Müller. I'm here from the Helmholtz-Centre for Environmental Research, UFZ. I'm the head of the department Environmental and Biotechnology Center, UBZ. It was planned to chair this session together with my colleague Ulrich Meyer, the CEO from the water company of Leipzig. He was here till 5 minutes ago, but due to a corona event in his family, he had to leave the UFZ spontaneously. Yes, in this perspective, my special thanks to the convener of the session, Maximilian Überham, who was in charge for the organization of the next hour. And I will start, sorry. The focus of the talk are blue-green infrastructures. What makes them interesting for the urban planning process is the question. They have a strong potential to act as a flexible tool to deal with the effects of the climatic change, namely strong weather events, heavy rain events, and droughts. What makes them unique is they are multifunctional, which means that they have distinct effects. We will learn in the next hours what this can mean. Exemplary, for example, green roofs are not only green roofs for us, they have a specific effect for the energy perspective of the building, but as well they can deal, for example, for the retention or for the storage of water, as to give one example. And so what we have to face for the urban planning effect is, on one hand, to deal with the heavy rain. The problem is overloading of sewers, losses of water, and we will speak about retention, storage, infiltration, and the evapotranspiration. And on the opposite, we are speaking about the dry weather, the droughts. Here the problem is that due to the droughts, dying off, loss of effectiveness of blue-green technologies, urban green creates problems. The measures we are speaking will be irrigation and cooling effects. And this perspective, we will start the talks, and Maximilian Überham will introduce the first speaker.
Yeah, thank you, Roland. Also welcome guests and attendees of the conference from my side. Our first guest speaker will be Professor Dr. Wolfgang Dickhaut. He's from the Hafen City University in Hamburg. And shortly to introduce him, he studied civil engineering at the Technical University of Darmstadt and specialized in hydraulic engineering, urban planning, biology, water supply, sewage engineering, just to name a few. And since 2006, he is working at the Hafen City University as the Dean of the Master Program, Resource Efficiency and Architecture and Planning. And he's also the head of the area Environmental Sound, Urban and Infrastructure Planning. And furthermore, he's the coordinator of the BMBF project Blue-Green Streets, where he will now give a talk on this project. Professor Dickhaut, the floor is yours.
Yes, thanks, Max, and welcome also from my side. As it is already mentioned, I will talk about a project funded from the BMBF, Multifunctional Streetscape Design in Urban Neighborhoods, or our short title, Blue-Green Streets. What you can see here is the dream of a future city with a lot of blue-green infrastructure, and our project, Blue-Green Streets, is focusing directly here to the streetscape. So how to integrate all these elements which you can see on this picture, even in such a very busy surface. It's a project with a lot of partners. I will not introduce all of them now because of the time, but you can see that there are other university partners as well as companies, and we are working with a lot of partners around Germany. I will talk about the vision of BlauGrün Street project, but I will focus mainly on two pilot projects which we are running in Hamburg's streetscape planning Königstraße and the treat pits in Müller. Let's start with the vision. In the beginning of our project, we formulated multifunctional blue-green streets bring traffic, water, microclimate, and landscape-related interests together and contribute to climate adaptation, as well as for better use possibilities and a better quality of sojourn. They consider existing infrastructures and economical frame conditions. So we wanted to stay near to the existing situation of streets and try to have a kind of multifunctional usage of the streetscape. The topics blue, green, and cool are our guiding targets. Some examples. We are talking, when we are talking about blue, to improve water storage to enable infiltration, but also to think about the pollution of the street water and try to find the right ways of treatment. When we are talking about green targets, I think in the middle is the quality of sojourn. So the quality of make it more useful for the people. We try to improve for this target the quantity and also the quality of landscape and try to improve the vitality of green spaces. When we are talking about heat protection or cool, we are talking about shading surfaces or to increase evapotranspiration. As I already mentioned, we are not focusing only in Hamburg. You can see some other cities in Germany, and in each of these cities we are dealing with several streetscapes. What is the approach to integrate these blue-green street elements, the BGIs elements as we framed it? The first aspect is, and this you can see here on the left-hand side, is that we try to reduce and reorganize the traffic lanes from individual motor and car traffic and to create for this, with this purpose, surfaces in streets for these BGS elements. So this is our most important aspect which we try to reach. But we also are looking in the nearby surfaces, create potentials for BGS in the nearby surfaces. I will explain it later on a bit more. And the smallest aspect would be to integrate BGS in existing street surfaces, as you can see here in the right-hand picture. What we try to integrate is a new cascade of BGS elements. Formerly, we had the situation that most of the water was discharged directly in sewer systems or in natural water bodies. After the new idea of water-sensitive urban design, a lot of projects are focusing in infiltration of water. But we think with the integration of blue, green, and cool that we have to use the water much more efficiently for the purpose of retaining, irrigating plants and evaporate the water back to the air to make it possible to use the water in a better way for cooling the cities. So to change the priorities of these elements of the water cycle. We developed and designed a lot of different elements. I will not introduce all of them here. You can have a look to our website where we present this more in detail. About the pilot projects in Hamburg, I will start with one project where I will explain the way of changing the streetscape. We are focusing on a street in the middle of Hamburg. A lot of traffic on it, 20 to 30,000 vehicles per day, and in a dense urban context. We started 1.5 years ago with this first map, this first idea of a plan of the reorganization of the street, which was designed from the authorities together with the company in the very beginning of the planning processes. And then we start thinking about integration of blue-green infrastructure. The first idea was try to reduce car lanes, and we did a calculation. We came to the decision that it will be possible from the traffic point of view to reduce, and we designed a huge new lane of blue-green infrastructure, which we now are planning much more in detail. We are just in the process together with the responsible authorities to do this. You can see here a picture and animation. Another aspect is to analyze nearby surfaces. And in this case, we are looking also in streets which are entering the main street. This is the Königstraße, and this is a neighborhood street. We designed a new pocket park in this area and tried to use in the future the water to irrigate this new pocket park in the area, or to use the water from rooftops to irrigate plants on the streets, because there we will have much more cleaner water. Some more pictures to illustrate this, especially when we try to use very small scale BGS elements, which brings the possibility to infiltrate the water. A last aspect, we are working with the topic of stormwater infiltration into tree pits. You will know that there are a lot of projects around the world, and we designed a new tree pit with the integration of water from the rooftops and with a new storage in the bottom of the tree pit, where we try to store water for a while to make it possible that the roots reach this reservoir to come better through the times of drought, which are much more often in Hamburg in the last years. So we designed this and we built this in the street of Höhlertwiete in Hamburg. You can see here some pictures from the construction area to half a year ago. It's now finished, and we started doing the monitoring because we work together with soil experts and plant experts to see whether the water management decision affects the trees, and whether the trees suffer with this new water, or whether they can use the water for better irrigation and for better and more vital development. So these are the main aspects which I wanted to present in this short presentation. Thanks a lot for your concern, and if you are interested, we can have a short discussion about this now, or you can contact me via these contact data. Thanks a lot.
Okay, many thanks, Professor Dickhout, to Hamburg. Yeah, now we will allow one or two questions from the chat. There's one question from Konstantin Suppé. I think he's from the City of Leipzig. And he has a question to your slide 20. He's asking, were there many conflicts with the citizens about car parking spaces when closing the road and creating the pocket parks? If yes, how did you manage this?
So in this special location, we didn't have problems with car parking space, but for sure this is a problem when we are looking to the whole streetscape design. But what we see is that nowadays in the recent street planning, you really are able to ask these questions, whether it is really necessary to have this amount of parking space in the streets, or whether we cannot use these places for other purposes. 10 years ago, this would have been impossible to ask this question. But from my perspective, what we learned in the project in the last 2-3 years, there is a new dynamic to to have and to create new solutions without too much cars in the streets. For sure, not at all without conflicts, but I feel a new dynamic in this context.
Okay, thank you for your answer. I think with the to keep the time, we go to the next talk. Thank you again, Wolfgang Dickhaut, and we will collect further questions for the discussion round. So we will have our next speaker.
Yeah, it's my special pleasure to introduce Dr. Manfred van Afferden. Manfred studied biology in Bochum and held a PhD in biotechnology from Bonn University since 2008. He is working in UFZ in my department as the head of the working group leader decentralized wastewater management. He is a speaker of BMBF-sponsored project, the Leipzig BlauGrün project. It's from the same research grant round Mr. Dickhaut already presented. And Manfred, the stage is yours.
So it's loading. I guess you can see the screen now.
No, it's nice to see you in the moment.
Not yet.
Not yet. Yeah, sorry, I pushed this button. Still not the case.
Yeah, take your time. I just realized that I forgot to give the title of your presentation. It is perspective of multifunctional water infrastructures at district level. Sorry for this.
Mm-hmm. It's now working or not?
No. Do we have die Backup-Folie? Sonst zur Not.
Yeah, please, Max, if you can charge it, then it would be great. I'm wondering that I can see myself, but
Or we skip to the next speaker and.
Yeah, maybe just we will jump to the next speaker and then Manfred will have more time to organize the presentation or to solve the technical problem. Or what may I ask the people from the technique? The next one, or? Ja.
Dann einfach die aufmachen, die PDF, die Nummer 2.
yeah, so that would be great, Max.
Ja. Okay.
I think now it's working.
Just say skip next slide, Manfred, and now you can start.
Yeah, thank you. So sorry to all the people in the virtual room that we took together. So I'm happy to present some brief results on the perspective of multifunctional water infrastructure, especially blue-green infrastructures. And the focus of the presentation will be these infrastructures between heavy rainfalls and drought. Next slide, please. So it was already introduced by Roland and some aspects mentioned in the previous presentation that management, local management, decentralized management of rain could have certain advantages for managing the whole water cycle in the city. Then we started to develop a model that gives us the possibility to demonstrate what will happen at the level of urban blocks if we are capturing the rainwater, and we try to include certain technologies. Please, the next slide. So one result of this presentation for urban district in Leipzig was that we simulated a very heavy rainfall of 100 years over 2 hours and 61 millimeters of rainfall. So this resulted complete in a amount of water of around 15,000 cubic meters. From this 15,000 cubic meters, we, in a traditional construction way, have a runoff of 10,000 cubic meters and the infiltration of 5,500 if we consider a good pervious soil with a permeability of 10 to the minus 4 meter per second. Principally in the traditional construction, traditional cities, this amount of water for this district would have been exported out of the city, and it would have been discharged either to a sewer treatment plant or to a natural water body. We did the same for another type of soil, a very compacted soil. And even, as you can see, there is nearly no infiltration, and the complete rainfall would have been exported out of the city. So our idea was to create a system at block level for zero outflow of these heavy rainfalls. Please, next slide. Hopefully this is working now with the animation. No, so I will try to explain it. You can see here a block, and we created a block of around 5,000 square meters with certain green space in the middle of the residential block. And the first model for this heavy rainfall as well, 100 years, 2 hours, 60 millimeters, indicated that we would need the whole inner green space of the block to infiltrate the water by certain technologies that are usually applied, like infiltration trenches. This, of course, gives competition in the use of the area of inner blocks. So in a certain way, we included as well green roofs, and so we increased the retention time, and we increased the retention volume for the rainfall. And by this, you can see the smaller area, it was possible to reduce the infiltration trenches to a certain percentage only of the inner free space. We applied this concept to a whole city district. Next slide, please. And here you can see in this, it was an animation as well for a 30-year rainfall event that in the existing city district, we would have a runoff of nearly 50% of the total precipitation, meaning from the 320,000 cubic meters, 150,000 are running through the sewer system out of the city. By implementing in each block a certain technology for infiltration, next slide, please, it was possible to reduce this export of water to only less than 1%, so meaning from the 320,000 cubic meter, 1000 cubic meter is generated as runoff and will be transported through the existing sewer. So principally, we extended and we use this type of model for other city districts. And if you have the space even within different dense areas, and you see the different colors that represent different dense areas. So the red color are building blocks or are residential blocks with very low space, free space. It is possible to build up a decentralized management even of heavy rainfalls. Next slide. So, and now we have another problem. It's not the extreme event only of heavy rainfall. We have another extreme event, and that are especially in the last years and affecting here in this area many cities, is the drought. So we have had some summers with nearly no rain, and if we solve the heavy rain events by implementing green technology, the question occurs how to do at the same time and how to maintain these green technologies in the time of droughts, mainly during summer. Next slide, please. Here only the example of a very dry year. It was 2018, where in our region we have had only 380 millimeters of rainfall. If you see in the upper diagram, there is the green line that represents the water holding capacity of the soil and the water content of the soil. And you see that by starting of May, the water content in the soil was nearly zero, meaning that the whole summer and even parts of autumn, we have had problems with drying up and dying off of a lot of trees and urban green spaces. We developed irrigation scheme, and you can see in the lower part of the diagram that in certain frequencies we can maintain, let's say, the water content in the soil to a certain limit, and this gives the possibility to have the whole year through green parks. And so from this point of view, it's everything possible, but there's a main question that arises. What about the water balance and where to take this water from? Next slide. Here now, this table, I will not go into detail by this, but the main question occurs: if the water that we have infiltrated during the times where we have had sufficient rainfall within the building blocks, if this water might be enough to maintain the green areas in the surrounding. So we build up a water balance, and you can see the red cells marked here, that even for the very dry year, we have enough water stored in the soil or in the groundwater to give irrigation to the green areas in the surrounding. Meaning that in total, if we are thinking in a way of balance, water balance, we have the situation in a city that the areas where the water is not infiltrating gives water. If we keep all the water in the city, gives enough water even to maintain green areas, and by water balance we even would have more water available in the city than for the green areas than outside the city. The way is how to access this water, and there are two possibilities. Next slide, please. These possibilities are cisterns or groundwater. And by implementing systems like this, communicating systems, synergetic systems that work with let's say, heavy extreme events for heavy rainfalls, but as well for extreme events like droughts, we have a tertiary third effect, and that is cooling. This is only a very brief estimation, but it shows that if we use this water for the city quarter and the city district I mentioned before, we would generate a cooling capacity of more than 400 megawatt hours per day in principle. Here, the question arises, of course, how to manage the cooling. So we have the cooling in the park, we could have cooling on the roof, we could have coolings, let's say, by fostering, by promoting tree growth. But all these aspects are around and communicating functionalities by blue-green infrastructures. So, and by this, I guess I would like to summarize only some brief things. Next slide. So that blue-green infrastructures in general could have a role for both extreme events, heavy rainfall and drought, the same infrastructures, so that extreme precipitation events can be managed by blue-green infrastructure at block level, and the precipitation that water remains at city level can be used for irrigation, and it is in that case that we investigated even sufficient for giving enough irrigation to the green infrastructures. So irrigation of city green can support cooling and avoiding heat islands. That is as well something to think in and to include into integrated water resource management at city level. Very important to not only think in one individual function, but to integrate the water resource management by all these aspects. So that blue-green infrastructure have great potential to maintain and restore the natural water balance in the city and strengthen thereby the city's resilience for climate change. Thank you very much.
Yeah, thank you, Manfred. Unfortunately, we are out of time now due to the technical problems in the beginning. And I kindly would ask, we have the questions in the chat and we will try to integrate them in the final discussion. Yeah, thank you, Manfred, at this point. And Max, will you please overtake?
Yeah. So our next speaker is Julia Palivoda. She's studying geography and urban ecology at the HU and TU Berlin. And her research focus is mainly on people's interaction with the urban biodiversity. And since 2017, she's a PhD candidate at the UFZ here in the department Computational Landscape Ecology. And she's working, was working in the EU project Urban Gaia with a long title, Managing Urban Biodiversity and Green Infrastructure to Increase City Resilience. And we are happy to welcome here.
Thanks, Max, for the introduction. Thank you for inviting me. And today I want to present some of the results from our joint paper here from the UFZ and with a colleague from the from the city's Office of Green Space and Water. It's about the development and management of Leipzig's green and blue infrastructure. And we want to introduce the citizens' perspective from an online survey. Well, just to give you a short background for those who don't know Leipzig so well, as many other cities, Leipzig is a growing city. There are lots of inhabitants and increasing inhabitant numbers. And of course, this leads to an increasing land pressure because, well, the city needs land for living, economy, mobility, but also for recreation and climate adaptation. Most people that move here, most people move to the residential areas near the city center, which you can see here in green. They have a very positive saldo in inhabitant numbers. And the city aims at steering and planning the increasing land take for those different purposes, and of course to prevent the ecosystem service provision in the city. And for this, the master plan Green 2030 is currently being developed to give you some short information about that, Master Plan Green 2030 wants to analyze the demands and functions of the green and blue infrastructure here in Leipzig, and also highlight important locally important spaces or sites of green and blue infrastructure. The strategy is hereby focusing on 5 major or main topics, which are, well, obviously not only relevant for Leipzig, but also for other cities and urbanization processes. These are biodiversity, climate change adaptation, environmental justice, health, and sustainable mobility. Oops. Okay. The process of the Master Plan Green development is characterized by a participation process with citizens. There were different events, forums, project meetings, workshops, and so on with citizens, and information events, so that citizens could participate and give their opinion to the strategy. One part of the participation process was an online survey that was conducted last year for a few months and was available online. Almost 3,600 citizens of Leipzig took part, and the online survey wanted to know, wanted to gain information about the use or the present actual use and valuation of Leipzig's green and blue infrastructure, as well as current problems and also conflicts that occur, and about the green and blue infrastructure situation in residential areas and in direct neighborhood of people's living environment. And the last part was about to integrate ideas and suggestions to improve, from the citizens' perspective, to improve the green and blue infrastructure in Leipzig. And this is actually the part of our analysis here. We analyzed the 2 open-ended questions in the survey, which are first about if people have specific ideas to improve Leipzig's green and blue infrastructure. And there we had more than 1,800 valid responses within this open question. And as a second question, people were asked if there were any further topics of green and blue infrastructure that are important to them, and if they should somehow be included in the Master Plan Green, or in the Green Master Plan. For the analysis, we categorized these open answers into different ideas and topics categories, and then we allocated these categorized answers to the 5 major topics that I just introduced to you. And well, of course, I cannot show you all of the results, but just to show you some most frequently mentioned answers. Well, regarding ideas to improve green and blue infrastructure here in Leipzig, there was a huge share of people who wished or suggested to include more rubbish and waste bins, included the rubbish topic. The rubbish topic was very important to them. And then can I actually point this? No, right. This doesn't work, okay. Well, and as a second most frequently mentioned idea, people wished for the preservation of present green spaces, and as well as most people suggested to plant more trees in streets or in parks or anywhere in the city. And interestingly, the topic biodiversity was very important to people. More than 10% of the responses somehow refer to biodiversity, with people that wish, for example, to implement wildflower meadows in parks, or somehow create habitats for animal or plant species. There was furthermore very often much mentioned the wish for regulatory or more regulatory authority in the public green spaces, which leads us to the conclusion that there are lots of use conflicts, for example, between people who walk their dog there and people being scared of dogs, or because of other groups of people being noisy, for example, listening to loud music or something else, or barbecuing. And these were the main issues for the respondents. The second question about further important topics revealed some similar results. Again, there were lots of people suggesting to increase the amount of green space in general in the city, preserving green space, and also they wish for less soil sealing and less housing construction in favor of green spaces. And here also most respondents referred to the topic of sustainable mobility. They wished for better infrastructure for cycling or for pedestrians, and also, for example, suggested to remove car parking space in the streets in favor of new green spaces or street trees, for example. Yeah, and also here the issues of cleanliness and rubbish issues in parks, as well as biodiversity, were again mentioned quite often. Yeah, as a next step, we allocated our ideas to the 5 major topics. And yeah, just very briefly here, you can see that biodiversity here in this blue color and environmental justice aspects, as well as sustainable mobility, were very much important to respondents. But in both cases, about or more than 1/3 of answers or responses referred to some ideas, suggestions and topics that we could not allocate to these 5 major topics. And yeah, as I was showing you before, they mainly refer to the quantity or the general quantity of green spaces here in Leipzig, including less building development in favor of green spaces, as well as the cleanliness issues and conflict issues with people suggesting to include more regulatory authorities in public green. Yeah. Well, these results will be published in a paper that is currently in preparation. And yeah, for further results of the online survey, you can actually see on the website of the city's Office for Green and Blue Spaces. Thanks.
Okay, thank you, Julia, for your talk. Also, due to the time, there are some questions, but I would save them for the discussion.
Okay.
Or we can do one. So from Sonja Knapp, she's asking, do you have information how representative the group of people answering your query is relative to all Leipzig citizens? So in terms of gender, age, socioeconomic status, and so on. Yeah,
that's actually a very good question. Yeah, we did look into that, and most of the people were academics, so it's not representative for Leipzig. There was a huge share of people with academic background. I haven't analyzed gender distribution yet, but yeah, I don't know. I think that was quite equal, the gender distribution and age. But yeah, it's a good point.
Okay. Thank you. So thank you again, and then we would continue with the next presenter.
Quick change. Okay. Yeah, thank you for the nice presentation. Now I'm going to introduce Corinna Schüttenhelm and Till Kugler. They will make a common talk. Mrs. Schüttenhelm studied spatial and environmental planning at the Technical University of Kaiserslautern and worked in engineering offices in the field of urban development, environment, energy and climate protection. Since 2019, she's working as the chair of urban planning at the TU Kaiserslautern and in the BMBF project BGIs. Mr. Kugler studied civil engineering at University of Stuttgart and works since 2019 as a PhD candidate in the Institute of Geoscience at the University of Stuttgart with focus on geothermal energy and as well in the BMBF project BGIs. And the title of their presentation is Sustainable Heat Management of Urban Quarters, Integrated Contemplation in the Urban Developing Process. Thank you. The stage is yours, I hope.
Hello, dear colleagues. My name is Corinna Schüttenhelm, and this is Till Kugler. First of all, we are very
as a better view? This looks good.
Hello, dear colleagues. My name is Ulrich, and this is the recruitment. First of all, we are very pleased that we can present our research project EVAS in this context. Sadly, we weren't able to make it to Leipzig, but we hope that we can all meet each other again in person soon. As we assume a different level of knowledge about the project, we would like to briefly show the project objectives and then present the current status. Subsequently, we look forward to your comments and the discussion. But first things first, who are we and what are we doing? The project EVAS is funded by the BMBF and part of the REST network. The project network is made up of scientific representatives like Till, that works on the Institute for Geotechnics at the University of Stuttgart, myself as the chair of city planning at the Technical University of Kaiserslautern, and a colleague from the Institute for Building and Energy Systems at the University of Applied Sciences in Biberach. Additionally, the City of Stuttgart is a partner in the network as our research area is located in Stuttgart. And to guarantee the relevance of the research project as well as the practicality, we are also partnered with the engineering office Klinger & Partner, the duct manufacturer of Frank GmbH, and the STEG as urban development company. So that's us. And what are we doing? The aim of our research project is to create a perpetual heat balance at the level of the neighborhood. Basically, the waste temperature of the premises should be used to cover the heating and cooling needs in the neighborhood. In our case, the neighborhood is the Rosenstein-Quartier in Stuttgart, which consists of tracks and railway siding, which will be abandoned when the train station is completed. In 2019, the design by ASP Architect was chosen as the winning design in the urban planning competition that the City of Stuttgart had announced. You can see the concept on the right-hand side. We used this design as the base for our development. And now you might think, well, this is not a revolutionary idea. So what's different than you with us? We want to achieve the balance by activating the anyway infrastructure in combination with an energy use.
So, by anywhere infrastructure, we mean sewers. We modified them by terminals, observers, and transport lines. A further innovation is called extraction or called transport, which will become increasingly important in the future, above all in view of global warming. The Rosenstein district in Stuttgart serves as the research area. And mentioned that the grotto is located in the middle of the core zone of the Stuttgart Medicinal Springs Zone, which means that the thermal use of the underground is subject to certain conditions. For example, it's forbidden to use glycol, so we cannot work with temperatures under 0 degrees, so the performance of our heat pumps are not so good.
Yes, it's a very interdisciplinary research project. The system must be planned in an orderly and coordinated fashion. And it becomes clear that individual specialist disciplines sometimes have a very different understanding of some terms, and maybe even think they have a better knowledge of the different disciplines than they actually have. You might also have experienced that. And for this proposed, the process of energy management planning as a method is examined more closely. There are many different names and approaches to the process, and we right now are in the process of working that out and working through.
So now to our system. The planned structures of block development. Each block is assigned a so-called hub, which is used to accommodate the supply infrastructure, parking spaces, etc. According to the current status, we will work with a three-stage system. First, thermal compensation should take place on the first level, the building level, then in a lifting area, and then on the district level. This should be supplemented by ice storage. The remaining requirement should mainly be covered by PV systems, geothermal energy, or solar thermal energy. So our sewers have a hybrid function. Firstly, they transport the wastewater. Secondly, they draw heat energy out from the wastewater. And thirdly, transport pipes are integrated into the cross section of the sewers to cover any excess heat that may be required. The developed concept covers all thermal requirements in the neighborhood. The first step by using waste heat energy. When all the waste heat energy is used up, the ice storage is emptied or filled for other state of consumption. At the end of the winter, for example, it's full of ice and you cannot use the heat inside. And the same way in the other direction in the end of the summer. In the final step, when all waste heat potential and storage capacity has been exhausted, heat energy is extracted from the wastewater. The reason is that this heat or cold cannot be recovered, as in the case of waste heat or ice storage. The energy will be destroyed with the discharge of the wastewater. Yes, we also made initial investigation about storage of heat in the ground, but the solar influence, the thermal influence of the wastewater and the low surface to volume ratio significantly reduce the storage efficiency, which is why we're now using ice storage. Yes, that's the current status of our research. And one aim we've also got is that we want to edit this project so that the result can be transferred to different neighborhoods very easily. Yes, that's all, and we are looking forward for your questions.
Yeah, thank you for being at time. I think we have time for one question again. Max, would you
in the chat is
select one, or is
no question at the moment in the chat? Maybe.
Okay, then I would propose that we continue and discuss this topic in the final discussion as well. So would you continue with Stefan Böttger?
Yeah. So we are coming to our last speaker, last but not least, Stefan Böttger from the Tilia GmbH. He studied industrial engineering at the Leipzig University, and since 2012 he's working as a project manager at Tilia GmbH and as also speaker of the sub-project energy management in our project, the BMBF project Leipziger BlauGrün. And Stefan, the floor is yours. We can see your presentation already.
Okay, thank you, Max, for the introduction. My name is Stefan Böttger. I work for the company Tilia, and as Max already told, we are part of the research project Leipzig BlauGrün. The project tries to develop new approaches for a new inner city urban district, which is called Leipzig 416. It's a complete new urban district with around 70% the area of living and 30% of services, gastronomy, etc. We have around 3,500 inhabitants in the future in the quarter. And as it is a new quarter, which is built more close or really close to the center, we have a lot of challenges and needs from the perspective of the energy supply. For example, we have a competition for land between energy technologies and other technologies such as stormwater management. And due to that, we have high requirements regarding innovation and sustainability, a sustainability demand for smart city approaches. And besides environmental sustainability, we also have a focus on economic efficiency as the area is developed by a private investor. In our approach, we develop certain scenarios for the energy supply and energy management. You can see our baseline scenario 0. We have a heating demand for the whole district of around 90,000 megawatt hours. We have a cooling demand of 1,800 megawatt hours per year. And for, let's say, household applications, we have electricity demand of around 13,300 megawatt hours. And connected to that, we determined the CO2 emissions as it is a main focus to develop a, let's say, CO2-friendly inner city quarter. For our baseline, we decided to supply the heat energy via district heating supplied by the local energy company, the Stadtwerke Leipzig. And using that, we have a CO2 emission of around 2,100 tons per year, which is already quite a good value if you compare to a system which would use gas condensing technology with around 4,800 tons per year. So this is just as a comparison. So already with this baseline scenario, from the perspective of the heat supply, we already have, let's say, good CO2 emissions. For the development of further scenarios, we choose the pathway of CO2 emissions. So that means in our next scenarios and the next step, we try to reduce these CO2 emissions, starting with our baseline scenario, which I described before. For green is the heat, the CO2 emissions for the heat supply, and blue for the cooling system. We already developed the next scenario, which we call economic optimum, using their already existing state-of-the-art technologies, but also, say, quite new and not so common technologies such as wastewater heat recovery. And due to that, we can achieve a reduction in CO2 emissions compared to the baseline scenario of already 20%. For our next scenarios, we try to reduce the CO2 emissions further. The next scenario we call ambitious, so ambitious in terms of CO2 reduction. And our final scenario will be a zero CO2 scenario. If we can achieve that, we will see. And to achieve that, we try to maximize the use of renewable energy sources for the whole district. In terms of heat generation, heat storage, electricity generation, cooling generation, and storage, and also including the application of blue-green technologies. To get an idea what let's say big portfolio of technologies we have, we developed this technology toolbox, or we are currently developing it. This is just the overview in the beginning. It's not yet finished. We have different branches from which we can use different technologies to develop certain scenarios, not just only for this district, so our district Leipzig 416, also for other districts in Leipzig or in other cities. So we have technologies for heat transfer, heat storage, electricity storage, electricity applications, heat generation. And what is, let's say, new are the application of blue-green hybrid technologies. So blue-green was already used in different contexts before. We see it as technologies combining water and energy systems. One technology out of this portfolio is a pilot plant or a pilot approach, which we developed together with the UFZ in the framework of our research project. We call it flow heater in combination with the retention green roof. And the idea behind it, so we can apply it for buildings or for, let's say, a whole district, is that we want to provide additional cooling in hot summer days or normal summer days by using groundwater, which is used for the irrigation, in combination with concrete activation, so cooling over the walls and over the ceiling, and to transfer this extracted heat on the roof in the stormwater retention space. We are currently building a pilot plant. You can see here the photo above of the current status. And in this pilot plant, we try to heat the irrigated water, or the water which is used for irrigation, by 6 Kelvin up to around 18 degrees Celsius. So the groundwater comes with around 12 degrees from the ground to the rooftop. To simulate our heat extraction from the rooms, we use a solar absorber as we don't have access to, let's say, room heating at the moment. And in the end, what we calculated so far, we have a theoretical amount of energy for heating, or let's say cooling, then in the future buildings of around 2,300 kilowatt hours per year for this green roof, or for this pilot plant. So in the end, let's say on the other side, it's a value of around 400 watts per square meter of green roof area of heating, which can be supplied. So we're currently developing this system, also with a, let's say, complex steering panel to simulate certain scenarios together with the research aim of retention. Furthermore, we're using simulation software, Top Energy is called, where we describe, or we show, or we implement our scenarios. So all the part of the scenarios we are developing, and there we have a very detailed overview of production and demand of heating and cooling. We can see in detail the heat requirements in living areas, for example, and also the specific global radiation when it comes to electricity production from PV systems. We not use this simulation software just for, let's say, fun and to make nice pictures in the end. The idea of the usage is that we simplify the operational management of the whole district, not just in terms of energy supply or energy management, also for other approaches such as water management. So this is not just a focus for energy, to let's say to bundle different approaches in terms of strategy. So if I want to maximize my CO2 savings, or I want to achieve the lowest energy prices in my district, I need some tools to achieve this, because the system is very complex. That's not just for the energy sector, also for the stormwater management, as we already heard before. So we have different technologies, we have different scenarios, external effects, so ambivalence, insecurity in the demand and in the production, and we want to use this tool to have a tool for the operation management in the end. So thanks for the attention, and yeah, if you have any questions, don't hesitate.
Okay, thank you, Stefan, for the final talk. Now we want to have all participants in the full screen, and we want to start our discussion round. And Julia, you can come to the front.
So, shall I start?
Yeah. You can start.
Okay, thank you to all for the interesting presentations. So we go a little bit away from each other. Yeah, highly interesting for me, and I know we have some questions in the chat room, but I would like to start the discussion with a question. I think in the middle of all the presentation, I understand that there was a close cooperation between science and the city, between, in our case, city, science and investor. And I would be curious how you deal with this kind of cooperation, how you bring your ideas into practice. What are the recommendations of your work, maybe for future work, for other cities, for other networks? I don't know who would like to start or to answer, but I can imagine that Mr. Dickhut and Manfred is very close to this answer, since you are moving yourselves in master plans already. Or anybody else who would like to start, as well as I think Tilia, Stefan, you are working in this perspective as well. I don't know, somebody please start.
Maybe in the order of the talks we could start.
Should I start with
Yes, please.
Okay. So for our project, BlauGrün Street, it was very important for most of the modules really to work together with the authorities. and to integrate our work in current street planning projects of the cities. So it's not only a scientific topic, but it's a topic try to change and administrational logics. And for this, we as researchers has to understand first what is the problem in this context. And we were very happy that, I would really say, and I did this already in my own talk, that we see that the current authorities, not only in Hamburg, are really very open to work together with the university in these topics, because they also see that they cannot continue with their current practices. So they are interested in integrating universities and research projects to find together new solutions. And for this reason, it's not so difficult currently to find partners in cities, from my perspective, because they are very open for this.
Okay, thank you for the impression from Hamburg and other cities, I think. Manfred, would you like to add something?
Yes, of course, it's a very important part of implementation projects, and I guess for most scientists, even it's as well an important thing to know that their thoughts one day might get reality, and this should be as well a strong motivation to contact the real world. And by doing this, I was really happy to see that the German, at least the German funding agencies in the last years, they supported even this collaboration, and they pushed a bit science to get in contact with practice. But you have to take the initiative, you have to talk to people, and you have to build up a confidential atmosphere. That is very important as well. And if everything works well, as it is in our case, we are really happy that we now are invited even in planning meetings. So we are not planners, and we have to clarify often that we are not the planning guys. They are sitting on the same table, but what we are, the role we could have are honest brokers, and if giving some ideas, and let's say not being let's say teachers and knowing everything better. And the understanding of the problem, the real problem, is the first thing we would like to learn, or would have had to learn by contacting them. Thank you.
Maybe that Stefan Betka has another answer, because I think you and your company are sitting in between as a consulting agency, more or less. You are sitting between research and for example, the cities or other contractors. What is your impression from this perspective?
So we are looking in, let's say, all directions. So as you said, we're sitting in between, and for us, it's a big chance, because when we have the input from the research side to get new ideas, we can try to facilitate this towards investor, or towards also as a mediator to the local government or the people in the departments who make the decisions. And my impressions is that they are interested in new ideas, but they are a bit restricted when it comes to legal regulations or affordability. So they like the ideas, but they need some proof and some let's say official way how they can bring it in their normal process. And it's also quite close connected to the persons themselves. So in the end, there are people working, and you have to convince them that it's a good technology you try to implement, or a new approach. So it's not just bringing in data. You have to talk very often and have a close contact to these people.
Any comments from Corinna and Till? Since if you are speaking about thermal activated sewer networks, I can imagine that somebody has to interact here as well.
Yeah, well, the city of Stuttgart is a project partner of ours, the Department of Environment. And we have, well, before Corona, we met in Stuttgart every 3 months for 1 week to work together. And 2 or 3 days at least, the representative of the city of Stuttgart was with us to work with us. And that was quite helpful. But we also have to say that sometimes if you have to like communicate with other people, like other than your project partners from other departments, yeah, it can be really like take long for emails or answers. And also they are very restricted, in my personal opinion, through like the politic framework and stuff. But that's just the reality, yeah.
Okay. Yes, thank you. I would propose to choose some questions out the chat room.
Yeah, we have collected some questions from the chat window, and I would directly forward them to you. One is to Wolfgang Dickhaut. Are the blue-green streets designed to work without artificial watering? And maybe a second, has the contamination remediation potential of plants being considered in this project?
For the first question, yes, we don't use drinking water for watering, for example, for irrigation. We try to collect the stormwater, try to store it, and then to use it for irrigation of the plants. So this is the main principle, and this should be a new answer in comparison to the practice which is on stage nowadays. And the new development in this direction is very important. So a concept irrigating plants with drinking water would not be a concept which we would accept in our context of blue-green streets. This is one, and the other question was about pollution of the water, I guess. So we do have one special project which where the University of Berlin is the main institution, and they are focusing mainly on treatment processes of treating stormwater from streets. They are looking for answers where in which parts of the streets it's we have to prioritize treatment facilities, for example. This is one question, and they do a lot of measurement in this context to find the typologies of streets and the spaces on the streets. And on the other hand side, they are working also in the direction of analyzing the treatment facilities, technical ones, and also more nature-based technical solutions. So if you are interested in this more in detail, you can have a look to our website. You will find the Institute of Technical University of Berlin, Professor Barenbuch, and his team is dealing with this concept.
Okay, thank you. So then to Julia, you told us about this online survey from Leipzig, and there was one question. Could you tell us more about how you recruited the participants? That's one question. And one from my side would be the watering of trees during droughts in the city is also a topic, rising topic in the discussion. Was this also a question in the questionnaire if citizens are willing to water trees in the city?
Yeah, maybe I will answer the second question directly. Yes, it was an issue. There was actually this idea and topic category of participation in maintenance, for example. There were lots of citizens asking or suggesting to be part of the maintenance activities, including watering trees, for example. So there was actually mentioned quite often. And also other maintenance activities. For example, people are very much willing to collect rubbish and trash in parks, or suggested to include some NGOs or do some events for like some cleaning events or something like that. So people are actually interested in maintenance and managing, be part of the maintenance. It's very interesting, actually. It's very cool. And regarding the first question, the online survey was not conducted by us, by the U of Z. It was set up by an AG Stadtlabor. So they set up the survey. It was available online, and I think there were some flyers and emails coming around. But I was not involved in recruiting respondents, so I cannot say much about it.
Yeah. Okay, thank you. Then one more question to Manfred. Also, Mr. Suppé from the City of Leipzig asked, did you include the building of cisterns in the project quarter, or is the water storage solely based on soil infiltration?
Okay, thanks for the question. Both options are still valid, so it's in discussion, especially for the new city district that is planned and where we are happy to be involved somehow. The irrigation of the park, that is nearly 5 hectares, will be established perhaps by a mixture of wells, so groundwater, and smaller cisterns. If you have storage of rainwater, especially water street runoff of stormwater from streets, and you would like to think in doing irrigation for a huger area, so parks, 5 hectares, of course, the cisterns will be quite big and expensive, and therefore we try to include groundwater as a concept for storage of infiltrated rainwater, with all the consequences of quality, etc., permitting, and so on. But for the city project in Leipzig, it's not yet decided what the percentage of cistern or groundwater will be.
Okay, thank you. So far there are the questions from the chat.
Okay. Yeah, I'm curious in one perspective to take the chance. We spoke about different kinds of decentralized or semi-centralized blue-green infrastructures, which will undertake their role in the city management. And my question would be, who will be in charge for this? What are the models in your cities? For example, speaking about operation and maintenance, are there any recommendations or already results, models, how to bring together this more or less new approach for the cities? Could you answer this? Maybe we start again with the northern part of Leipzig. Sorry, of Germany.
Germany is northern part from Germany, but not from okay, so yes, it's a very interesting and very important topic. It's not only a topic of finding the right technologies, but especially finding the right new processes for maintenance. And we are just doing this work to think about with the authorities here in Hamburg about who will maintain these regals which we build together. And we want to take this and the findings out of this discussion as a kind of role model to try to link it and try to bring it to also the other elements of blue-green streets elements which we define. So it's a really very complicated and detailed discussion about this. We should involve, in this case, for example, at least 4, 5 different stakeholders who are normally in charge to do this maintenance of these kind of elements, and they have to set together a new process how to do this. And we are running workshops to discuss this and try to decide for such kind of concrete elements. And we will run in March next year a first workshop which is dealing especially with this topic, and try to present our own preliminary results and invite a lot of other cities and do the concretization for this topic. We will additionally do questionnaires in our project in Hamburg, but also we hope we will do this in Berlin and Solingen as well, to involve also other authorities. And so it's a very crucial topic, very detailed and complicated, because we have to change the role modeling of the process in the cities.
Yeah, thank you. I think Stefan Böttger has some ideas about this as well, since I know that it's a part of your business as well.
Yeah, of course. As I already mentioned, we're already thinking about this operational management for infrastructure. So in our case, which I presented for energy distribution, the energy system. But of course, it's a general question. The question is not from my point of view, who will it be? It's more how it will be financed. And that is because this is a main question. Will it be in the end? It will not be one entity, let's say, who finances it. It will be a mixture. So if we talk about a district, it will be a part for the investor. It will be also a part for the public authority to finance. In case, for example, for stormwater management, when we talk about these blue-green technologies, Baumregole, that it will be a mixture of financing, and then it's one entity which can also be which can consist of public authority and private part for the technical support, which then cares about the operation of these systems.
Okay. And Julia, what is the role of the individual citizen in this model? So operation maintenance means for the citizens on one hand. Do you have any ideas in this perspective?
Yeah, I mean, in this case, I can only talk about the citizens' perspective, as this is what we were analyzing. And yeah, as I was saying earlier, I mean, obviously there's lots of interest and people are willing to somehow contribute to maintenance. The question is how realistic it is, if they will be willing to, I don't know, finance this, or at least partly finance maintenance activities, or yeah, for example, just spending some time due to events or maintenance activities they do themselves or in a group or with NGOs or citizens groups. That could definitely be an option. At least this is what people told us in the survey. If it's realistic, I don't know, I cannot say.
Okay. Yeah, I don't know. Any comments from you, Corinna and Till? Operation maintenance, in your case, will probably have something to do with the water companies in the city, I can imagine, or are there other ideas there?
Yeah, we are discussing different operator models, and also, for example, like what we can apply, like connection and compulsory use or something, because it's a combination between water and energy, and the combination of both makes it quite complex. And additionally, in Stuttgart, there's a very complicated situation regarding the municipal suppliers, so Stadtwerke, and the energy agency. They have to figure some stuff from the last years out, and it's very complicated, and we are talking to the city, and yeah, we don't have results yet, but we are looking yeah, how we can handle it. And also, like Stefan Böttger said, it's also questions of finances, because the sewers that we plan, of course, are more expensive than usual sewers. And we are working through that, but have no results yet.
Mm-hmm. You have one additional aspect?
Mm-hmm.
Okay. So for sure, it's a question of financing, but the question who will finance is together with the question who is responsible and who is in charge of this. And what is the problem? What we see with the blue-green infrastructure is that especially the authorities who are responsible for the greenery in the cities do not have a very good budget for maintenance. I guess it's a bit the difference to the water agencies. But when we now want to use the green infrastructure to solve problems from the water management, then the first question is, we do not have at all enough money to do on our own maintenance without having the water problem on our surfaces. And now you come with a new problem or a new aspect, and we have to finance this as well. So they see it that the water problem should be solved with the costs of the greenery or greening institutions. And this is a main, from my perspective, a main problem. It starts with communication for sure, but it comes together as well with the topic that there is much too less money for maintenance, for greenery, I think, in each city in Germany. And when I was outside Germany, for example, in Asia in the last years, I saw how much maintenance they put in dealing with maintenance of greening in the middle of the cities. There's a huge difference. In our country, we do not have a so huge focus on this. And this has to be discussed and has to be solved. And as we all, I think, considered, it's a really complex situation because we have to change the processes for all of this.
If I can maybe add something. So I fully agree with you. The question of financing is also one step before. So who will give the money to the, let's say, greenery company? From our point of view, also the citizens or the inhabitants of each quarter are, let's say, a bit more responsible in terms of financing this. So when we speak about the new district, it's also possible, just for example, that you integrate, let's say, a small fee in the price for a flat or in the rent, so that you have a normal regular payment, which then goes out to this operation company or the greenery department, which cares about this new approaches or technologies. So if you want to have additional value, somebody has to pay for it. And it's also a learning process for the citizens themselves. They know it's getting warmer, it's getting hotter, we have water stress, but to handle it, there has to be say financial distribution from all of the people who benefit from that. They have to pay a little amount for that.
Okay. Yeah, thank you. I don't want to interrupt this final discussion. I think it was worth to to do this. I think our time is more or less over, and I do not want to repeat the interesting content of all those talks. Thank you to all of you. It was highly interesting, excellent presentations, and thank you for being here and answering all the questions. Thank you again, Max, for the organization of this session. And what I take with me is that it's really, I think, worth that our disciplines work together. What I think we see is that we have a complexity of things to solve when we would like to implement blue-green infrastructure in a growing or existing city. And I think it's worth that science, consultancies and the city and investor work together, and maybe in a kind of co-design we can face the challenges for the city of the future. And maybe we stop here. Thank you again, and if there are other questions, I think we will find ways to answer them. Goodbye.
Thank you. Goodbye.